Now that you have watched Exponent Rules Part 1, we are going to continue our study of exponent rules. At the end of this lesson, you will still be able to simplify expressions using exponent rules. They're just going to be a little bit trickier. Before we get into actually using those, in the Part 1 video, we just very informally discussed the exponent rules. I am going to just write some formal power or rules just in case you would like to have them in your notes. So I know that I wrote in the first video, I had x to the a times x to the b. When we're multiplied by something, we just move up powers. So we found out that we just add the powers. Of course, all the bases do need to be the same. All right, and then we found out that if I had x to the a over x to the b, when we're dividing, we were just moving backwards, or we are subtracting the powers. So this would really be x to the a minus b. So if you see something like that, we end up subtracting the powers. And then if I had like x to the a raised to the b power, when we wrote that out, we ended up multiplying the exponents for the powers. But each of these, I'm not super concerned about you having the formal definitions because especially if you need to write it out, you may. These are just helpful for you if you are wanting to just go by powers strictly. All right, and the biggest thing is however your brain works is how you should work these problems. So you do it however you feel, and I'll try to work them both ways. All right, on most of these examples, I'm going to do an example, one or two, and then I'm going to have you do one. So please make sure when I do say pause the video that you actually pause the video and try it on your own. Okay, so notice basically what's going to be happening. We're just going to be taking the rules that we did in part 1 and adding some more variables, adding numbers, all sorts of things to this. All right, so you'll notice that we have 3x to the 4 times 7x to the 2. The biggest thing we're going to do on this one, I have some numbers and I have some variables, so we are going to split them. So this is really going to be 3 times 7, so I'm going to put the numbers together, and then it's going to be x to the 4 times x to the 2. So we're just going to split them into 2 separate parts and then deal with them separately. So first of all, this says 3 times 7. We know that 3 times 7 is 21. And then it's this next part, if you recall from the last part that we worked on, if I have x to the 4th power and I'm multiplying by 2 more x's, we are going to get x to the 6th power. And again, if you needed to write that out, we had 4 x's and then we multiplied by 2 more x's. Notice I end up getting 6 x's. So my answer would be 21x to the 6th. So now would you please pause the video and see what you get. Alrighty, welcome back. Please remember in this one, we are going to take the numbers. So we're going to put 2 times 4 together, and then we're going to put x to the 7 times x to the 3 together. 2 times 4 we know is 8, and then if I have x to the 7 times x to the 3, I had x to the 7, I'm bumping up 3 more x's, which is going to give me x to the 10 power. So hopefully that is what you got. Okay, this third example I'm going to do with you, again, just like I did in the first two, we are going to put the numbers together and then the variables together. Okay, and when I do that, we know that 5 times 3 is equal to 15. And then here, if I'm at a to the 4, and I'm multiplying by -4, a couple different ways that we could look at them. If I have 4 a's, and then I need to basically divide by 4 a's, notice I'm really left with nothing, but we will discuss what I mean by nothing. If we subtract them, 4 plus -4 is 0. Okay, we found out from the last video that anything to the 0 power is equal to 1. So we really are left with 15 times 1, which is 15 is my answer on that one. So we've just remembered that anything to the 0 power we have already established is 1. All right, next example. I will do the first two and then I'll let you do the last one and see how you do on it. Okay, on this one you'll notice doesn't really look like there's anything to do other than there are negative exponents and we are not allowed, so no negative exponents allowed. Okay, so if there are no negative exponents allowed, what we are going to be doing on this one is just making sure there are no negative exponents. So if you look at this one right here, this issue is y to the -2. The 3x to the 5, they are fine. So another way, I'm going to do this a couple different ways and you can just decide which way makes more sense to you. So the 3x to the 5 is all set. And please remember when we were subtracting, it was the same thing as dividing by 2 y's, so we had 3x to the 5th, and this y to the -2 means instead of multiplying by it, we are going to be dividing by 2 of those y's. Okay. Okay, another way that we could have looked at this, which I think is a little bit harder if I had 3x to the 5th, we know that y to the negative 2 is rewritten as 1 over y squared. And then multiplying across, I get 3x to the 5 over y squared. All right, I think my first way was a little bit easier, so hopefully we'll just stick with that. All right, so on this next example, I have 5a to the negative 3, b to the 7. So I'm going to deal with this a to the negative 3 right here. The 5 and the b to the 7 are totally fine. If I am multiplying by a to the negative 3, that really means I'm dividing by 3a's. So there we go, and we are done. That's really all there is to it. Okay, I'm going to let you pause the video, try the next part, and see how you do. Alrighty, let's see how you did. 2x to the 4y to the negative 8. The y is the issue because it has a negative power, so 2x to the 4 are totally fine. Multiplying by y to the negative 8 is the same thing as dividing by 8y's. So we get 2x to the 4th over y to the 8th, and that's really all you need to do for that one. Okay, number 3 again, I'll do the first two, and then you get to tackle the last one. Okay, same thing that we did on the first example. We're going to take our numbers and put them together, and then we'll take our variables and put them together. So here we have 27 divided by 9, which will be 3. And then if I have x to the 7 and I divide by x to the 3, we know if I'm moving back, I'm going to subtract those powers. So 7 minus 3 will be 4. Or again, if you want to do it out the long way, we had 7 x's and we divided by 3 x's. So notice I'm left with 4 x's if I do that. Okay. The next one, if I have, so my answer is 3x to the 4. My next one, I'm going to take my 5/9. I'm going to take my x's and put them separately. And I'm going to take my y's and put them separately this time. Okay, so if I do that, I have 5 divided by 9, which 5 divided by 9 does not work out nicely, so I'm just going to leave it as 5/9. If I have x to the 9 over x to the 2nd, I'm going to be subtracting those exponents and get x to the 2. And then for the y's, same thing. I'm going to be subtracting those exponents because I'm moving backwards because I'm dividing, and I'll get y to the 3. So that would be my answer. And again, if you need to draw those out, you go right ahead and draw them out. Okay, I'm going to let you pause the video and try the last one. Okay, let's see how you did. We're going to put the numbers together, and then we're going to put the variables together. So here we have 12 divided by 4, which will be 3. And then if I have x to the 8 and I'm moving down by dividing x to the 6, we'll subtract and we'll get x to the 2. Okay, example 4. This time I'm just going to work one problem and then you're going to work one problem. Couple different ways that you can work this one. And I'll show both of them. Whichever makes more sense in your brain is the way you should do it. Okay, so this means this 3 out here means I'm going to write 3x to the 2nd 3 times. Okay, and then I'm going to put all my numbers together. And then I'm going to put all my variables together. Okay, so that is one way. 3 times 3 times 3 is 27. X to the 2, if I have 2 x's and then another 2 x's and another 2 x's, I now have 6 x's. So it'll be 27x to the 6th. All right, another way of working this problem was I could have just separated, I'm going to put a 1 on that 3, by multiplying my exponents. I'm going to have 3. 1 times 3 is 3, and then x 2 times 3 is 6. And then 3 to the 3rd power means 3 times 3 times 3, which is 27 x to the 6. So it really doesn't matter which way that you work it. I kind of almost think that this way might be a little bit easier, but I'm going to leave it up to you, whichever way your brain feels like thinking. All right, I'm going to let you pause the video and try the next one and come back and see how you did. All right, hopefully you're back because you tried the problem. I'm going to write this out 4 times. So this means 2x to the 9th times 2x to the 9th times 2x to the 9th times 2x to the 9th. I'm then going to put all my numbers together. So 2 times 2 times 2 times 2, and then x to the 9, excuse me, times x to the 9 times x to the 9 times x to the 9. All right, 2 times 2 is 4, times 2 is 8, times 2 is 16. And then, let's see, I have 9 x's and then another 9 x's and then another 9 x's and then another 9 x's. That would be x to the 36. Okay, so let's do it. If you worked it the other way, I could have put a 1 on that too. So I'm going to have 2. 1 times 4 is 4. And then x, 9 times 4 is 36. 2 to the 4th power means 2 times 2 times 2 times 2, which is 16 x to the 36. So notice you get the same answer both ways. You decide which way is best for you. Okay, number 5, just continuing along here. r to the second, s to the 7, t to the 3, times r to the 6th, s, t to the 9th, to the 4th. All right, first thing that we're going to do, we have lots going on here, but let's just get rid of those parentheses first. This means we're going to be writing this 3 times. This means we're going to be writing it 4 times. Feel free to do that, but because this is a longer problem, I'm going to go ahead and know that if I see those parentheses, I'm going to be multiplying my exponents. So I'm going to have r, 2 times 3 is 6, s, 7 times 3 is 21, and t, remember if it doesn't have an exponent, there's an invisible 1 on it, so t, 1 times 3 is 3. Then I'm going to bring down that dot, okay, and then I'm going to have r, I'm going to have r, 6 times 4 is 24. There's not a variable on the s, I'm going to put an invisible 1 there. 1 times 4 is 4. And then t, 9 times 4 is 36. Now we are not done yet because we've got some stuff going on. Here I had 6 r's and then another 24 r's. So altogether that would be multiplying 30 r's. And then if I look at my s's, I had 21 s's and then another 4 s's. It's going to give me 25 s to the 25th. And then t, there were 3 t's and then I multiplied by another 36 t's. So that will be t to the 39. So that would be my answer on that one. And again, if you wanted to write it all out, you're going to get the same answer. So I'm going to let you do number 5 and see how you do. Alrighty, hopefully you're back and you're ready to check and answer here. The first thing that I'm going to do on this one, again, if you would like to write it out 7 times and 4 times, go for it. I'm going to multiply my exponents. I'm going to get x to the 14th, y to the 21, and then here there's not anything on the x, so I'm going to put an invisible 1. 1 times 4 is 4. And then y, 5 times 4 is 20. And then if I put my x's together, having 14 x's being multiplied by 4 x's, it's going to give me x to the 18. And then y, if I had 21 y's, I multiplied them by 20 more y's, that would be y to the 41. Okay, number 6. We have y to the 4th times negative 2x to the 4th. Again, there are a couple different ways that we can work this problem. This time I'm going to, because that negative 2 is in there, sometimes that gets us confused when we try to multiply. So I'm going to go ahead and, well, you know what? Yeah, I'm going to write this out 4 times this time, but I'll show it both ways. 4 times, and then this, the negative 2x times negative 2x times negative 2x times negative 2x. So then I end up getting, let's see, we're going to have, if I look at all my x's, 1, 2, 3, 4, 5, 6, 7, 8 x's. I have 1, 2, 3, 4 y's. And then negative 2 times negative 2 times negative 2 times negative 2 is a positive 16. Okay, another way of looking at that one, I could have put 1s on here and multiplied. I'd get x to the 4, y to the 4. And then times, if I had put a 1 here, this means negative 2 to the 4th power, and then x to the 4th power, because again, 1 times 4 is 4. Notice again, I still get x to the 8, I still get y to the 4. The biggest thing on this one is I do have to do negative 2 times negative 2 times negative 2 times negative 2, which gives me 16. All right, I'm going to let you pause the video and see how you do on this one. Alrighty, let's see how you did. Okay, so I'm again 2 different ways we could do it. I'll do it both the long way and the shorter way. 3x times 3x, and then xy times xy times xy. 3 times 3 is 9. 1, 2, 3, 4, 5 x's. And then 1, 2, 3 y's. And another way that I could have done that, put 1s on things. Multiply my exponents, get 3 to the 2, x to the 2, times x to the 3, y to the 3, and I will end up with the same answer either way. Okay, problem number 7. We have 2 things going on here. Let's take care of the numerator first, and then we'll take care of the x to the 3. So I know if I had 5x to the 5th, and I'm multiplying it by x to the 11, I'm at x to the 5th, I'm moving up 11 more x's, which is going to put me at x to the 16. I'm going to divide it by x to the 3. So we know that if I'm at x to the 16 and I'm dividing by x to the 3, we're moving backwards 3 spaces. So I'm going to subtract and I'm going to get x to the 13th. And again, you could, if you didn't remember the rule, you can always write out 16 x's, write out 3 x's, and see what cancels. Okay, I'm going to let you try the second one. Okay, let's see how you did. If I have the next one, x to the 3 times x to the 9, I'm going to add my x's and get x to the 12. And then on the bottom, I still have x to the 7. I know at this step I'm going to subtract because I'm working backwards, so I'll get x to the 5. Okay, number 8. These look kind of crazy, but we got them. They're just a little bit longer. Okay, what I'm going to suggest doing on these ones is let's deal with the top, and then let's deal with the bottom, and then we will divide when we're done. Okay, so if I'm dealing with the top, x to the 2nd and x to the 3rd, since I'm moving up, it's going to be x to the 5th. We're just going to add those exponents. And same thing with the y's. There's an invisible 1 on the y. So y to the 12 and y to the 1 will be y to the 13. Okay, on the bottom, we're going to have x to the 7, and then there's another x that I'm bumping up. So it's going to be x to the 8, and then y, 4 plus 3 will be 7. And now from here, if I'm dividing, remember we're going to be subtracting the exponents. So I'm going to end up getting x to the negative 3 because 5 minus 8. If we started at 5 and we move down 8, we're going to end up down at negative 3. And then 13 minus 7 is 6. All right. And then from here, we know we're not allowed to have a negative exponent. So the y to the 6 is good. Multiplying by that x to the negative 3 is the same thing as dividing by, when we're working backwards, dividing by 3x's. So that would be my answer for that one. Alrighty, we could have also written that out, especially if the negative confuses you. If you would have written it all out, we would have ended up with 3 x's on the bottom that did not cancel. So I'm going to let you try the next one, come back and see how you did. Alrighty, next one, here we go. If I have, again, I'm going to deal with the numerator and the denominator, add those exponents, x to the 8 and x to the times x to the 6 will be x to the 14th. Y, where there's an invisible 1 and plus 8 would be y to the 9. In the denominator, x to the 4 times x to the 2, add those exponents, we'll get 6. And then y, add those exponents, 7 plus 5 will give me 12. And then again from here, if we're dividing, we're moving backwards. So I'm at 14, I'm going to move down 6 x's. That's what I'm going to subtract. I'm going to get x to the 8th. And then y, if I'm at y to the 9 and I need to move down 15 spaces, that's going to put me at y to the negative 6. All right. And then from here, my x to the 8th is fine. But if I have a y to the negative 6, that really means that I'm dividing by 6y's. So that would be my answer. And again, if you wrote that all out, you would notice that you ended up with 8 x's on the top that did not cancel out and 6y's on the bottom that did not cancel out. Okay, last problem. Here we go. Again, this looks a little tricky, but I think we got it here. 2 different ways to work it. We can handle the parentheses, or we can handle the division first. I think that I am going to, let's see here. I think I'm going to handle that, and I actually did not want this to be, I think I want this to be a 4 and this to be a 3, so if you would change that just so it works out a little bit better, that would be great. Okay, so now we have x to the 5, y to the 4 over x to the 9, y to the 3. I think what I'm going to do first is actually multiply. So we have this 7, so we get x to the 35, y to the 28, and then I have x to the 63, y to the 21. Okay, and now from here, since we're dividing, we know we're going backwards, so we're going to be subtracting the exponents. I'm going to get x. If I'm at 35 x's and I need to move down 63 x's, that's going to put me at a negative 28, I believe. Yes, I feel pretty good about that. Okay, and then y, if I was at 28 y's and I had to move down 21, that's going to leave me at y to the 7. And then we're not allowed to have negative exponents, so I'm going to be at y to the 7. And then if I'm at an x to the negative 28, that really means that I'm dividing by 28 x's. So that would be my answer. Okay, we could have, if we wanted to, it started with subtracting. That would have gotten us the same thing. I just want to show you if I had x to the 5 over x to the 9. Subtracting, I'm going to get x to the negative 4. And then 4 minus 3 would have been 1. And then taking that to the 7 power, we're going to multiply. We'll get x to the negative 28. Y to the 7, and notice it puts us in that same spot. So really, whichever one you prefer to do first is what you should do first. All right, now the last one. Please pause it and see how you do and come on back. All righty, hopefully you're back and you're ready to check. I'll work it both ways again, and you can decide which way your brain works better with. I am going to go ahead and get rid of my power first. So if I multiply everything by 5, I'll get x to the 35, y to the 10, and then I'll get, excuse me, x to the 15, y to the 20. And now from here, I know that I need to subtract my exponents. So 35 minus 15 will be 20. And then y, 10 minus 20 will be negative 10, because I'm at 10 and I have to move down 20 spaces. And then from here, the x to the 20 is fine, but we know that multiplying by y to the negative 10 really means dividing by 10y's. So that would be my answer. Now, if you worked it the other way, subtracting first, 7 minus 3 would be 4. 2 minus 4 is negative 2. And then bringing it to the fifth power, x to the 20, y to the negative 10. Notice again, you get the same answer either way. So hopefully now you really know how to simplify expressions using exponent rules.